It happened again. This is like my third video on server component CVEs this year, and I don't even think I covered all of them. This time it's 13 CVEs, yes, 13 of them across React and Next.js, 6 of which are high severity and include denial of service, middleware bypasses, cross-site scripting, and more. Maybe server components were a mistake. So here's the Next.js security release, just fixing a few casual issues in here that they've had this month. And down at the bottom, obviously the resolution is to upgrade all of your Next.js versions, and these are the impacted versions. It's worth noting, TanStack is not impacted by this, which I might be biased, but that's another reason to use TanStack for me. Now, I won't go through all of these as we'd probably be here for a while, and I also haven't found working exploits for all of these, but I do want to show you one from each category, and we'll start out with a middleware and proxy bypass, and the one I've managed to recreate is this pages router one. So we have a middleware proxy bypass in the pages router if you're using i18n, and you can see this is a CVE with a 7.5 out of 10 severity. This is an example of a vulnerable application, so in the Next.js config, I've turned on i18n and also set up 2 locales, so English and French. Then I also have a middleware file, which has actually been renamed to proxy in later versions of Next.js to try and avoid the confusion that I'm about to show you. But essentially what middleware should allow us to do is modify an incoming request, whether that's by redirecting it, rewriting it, adding in some headers, or anything like that. In my case, I'm using it, so we try and visit the /secret page. It checks if they have a session cookie, so they're logged in, and if they're not, it should redirect them to the login page, so hopefully only auth users should be seeing my secret page. At the bottom, we also have a matcher, so that any middleware that we're applying to that secret page is also matching the locale variants of them, because technically now, since we have 2 locales, we have 3 versions of this URL. In the secret page itself, I then also have some server-side props, so these should be fetched off the server at render time, and again, since we set up that middleware, theoretically, only a logged-in user should be able to see what these values are, which I then later use on the page itself, so an email, a flag, and also a headline. Again, only an auth user should be able to view these. Let's put that to the test then, and the first thing I'll try and do is access that secret page, and you can see I'm redirected to the login since I'm not logged in, which means our middleware is working. But what if we turned into master hackers? Well, we could do that by first inspecting element, absolutely crazy hacker stuff, and then in the next data script down here, we need to look for our build ID. So in my case, that's this one here, and we can go ahead and copy that. Then we need to type in a URL, which is _next/data/ the build ID that we just copied, and then the page we're trying to access .json. Once you've done that, you can see we get back those props that should have been behind that middleware and protected, which in my case was a flag, email, headline, and also something telling you to subscribe for more developer news, tutorials, tips, and tricks. So go ahead and do that. I hope I've impressed you with my crazy hacker skills there, but why does this actually happen? Well, this one is as easy to explain as it was to do. Since we had our secret page and some server-side props, in Next.js, server-side props are served from a URL that looks like this, but our middleware should have been protecting this route. The trouble is, since we were using i18n, we also had 2 other URLs, which was the English and French variant. And you can see that server-side props also get the English and French variants as well. And Next.js just had some faulty code, which meant if we did have i18n enabled, it wasn't protecting the base case. So this wasn't included in the matcher, but the other 2 were. So English and French versions were protected, but not the base case of /secret. We can see that really quickly. If I just change this URL to the English version, I do get redirected to the login page. An incredibly simple vulnerability then, but I'll be honest with you, these middleware bypasses often sound a lot worse than they are. They're not great, but you shouldn't really be protecting much with just middleware anyways, and Next.js don't even recommend that you do this. If you did have some sensitive data in those server-side props and you had no sort of server auth logic, well, I feel like part of the issue is on you as well. So let's move on to a more damaging one, which is denial of service. There were 3 of these, but there was only one that I could reliably recreate, and that was this one here, which is denial of service with server components, and this impacts Next.js as well as anything using the React Server DOM package, which is pretty much just Next.js and the other frameworks that have copied it, like Vnext and a few of the other forks. TanStack Start doesn't use this, so it's not vulnerable to it. You can see this also has a severity of 7.5 out of 10. With this one, all you need is a very simple Next.js application, and in it, you need to be using a server action, but again, it can be a very simple one. This is that site up and running, and you can see when I refresh the page, there is pretty much no loading. It is nearly instant. And to put some actual numbers behind that, if I send this request, you can see it resolves in 0.02 seconds. But if I now go ahead and run my exploit, and then send that request again, this time it took 6 seconds, and that was from me running the exploit once. So imagine what would happen if I chained it. Now, to understand this exploit, we need to know a little bit about the React Flight Protocol, which is the format that React uses to serialize component trees and data between the server and the client. You've probably actually seen this before. So on this page, we had a form that had a server action. If I go over to the network tab here and click send, you you can see that the payload actually gets sent as data that looks like this, which kind of looks like gibberish, and the same for the response here. But if we go ahead and copy this payload, I can explain what happens when it's sent to the server. The first step is deserialization, and it will start on chunk 0, where we have this $K1. This $K1 is actually just a pointer saying there's going to be some form data here that starts with 1_. So it will take all of the other keys that we sent over as part of that payload, it will pass over all of them and look for a string that starts with 1_, and it will know this will be the key and that this is the value. So once it's done that, it can say we have name, email, and message, and it will simply turn this data into this object that we have down here. Nice and simple. The trouble with this approach though is what happens when we scale it. Say I add in another pointer, this time looking for K2, this is going to look for all of the keys that start with 2_. The trouble is now, when we're on K1, it's going to pass over all 6 of these, looking for the ones that start with 1_, and when it goes to K2, it's going to do the exact same thing, but looking for the ones that start with 2_. So we're now passing over 12 keys in total. Now, that's not too bad, but let's take this to the extreme. If we add in 199,999 random keys to the payload that we're sending over, and then we change our array on 0 here to go K1, K2, all the way up to K1000, that means it's going to have to look for 1_, 2_, 3_, all the way up to 1,000_, all over our 200,000 keys that we have in our payload, and that means in total it's going to do 200 million string comparisons. As you can imagine, that is going to block the thread for a fair few seconds. This is the commit that I believe fixed the problem that we were having. You can see there is a lot going on in this commit, and to be honest, it's a little bit complex. But to try and explain this the best I can, essentially now they use a cursor-based system for the keys, so they load in all of these 200,000 keys that we sent in our payload into a list, and then we start on 0 here where it's looking for the K1 reference, and it starts going down that list with a cursor that cannot go backwards. So it goes down here to junk 1, it sees that doesn't match the 1_ that we need, so it goes to junk 2, that doesn't match 1_ either, so it continues all the way down this key list down to junk 199,999. Once it's reached here, it realizes there is no match for K1, so it moves on to K2. Now K2 starts looking for 2_, but the trouble is, since this is a cursor-based system and this cursor cannot go backwards, it immediately runs out at the end of the list, so that is also going to be undefined, and that continues all the way up to K1000. So now this time, we've only gone over 200,000 keys. Essentially, this fix has taken the number of operations down from k times n, where k is the number of k references we have, and n is the number of keys, all the way down to n plus k. So in our case, we went from 200 million operations down to 201,000, since it does still need to go over all of the keys and also those k references. I think this tweet from Prime really sums up the situation we're in. Making your own protocol with serialization is incredibly hard, so it's not surprising that we're seeing this many issues. In my opinion, they need to get Claude Mythos to do a once-over on the React and Next.js codebase. Next up, we have the highest severity CVE of the lot, which is server-side request forgery in Next.js applications. You can see this one is ranked 8.6 out of 10, but it is also worth noting that this one didn't impact for cell-hosted deployment, so only self-hosted or other providers. This exploit is also super simple to take advantage of. First, we need to launch our Next.js server, and again, this can be a stock Next.js application. You don't have to make any modifications. Next, we're also going to want an internal server. So say this server could only be accessed by the Next.js server and not by the outside world. Say this was on our cloud deployment. Then what we're going to do is simply send a very simple curl request, where we send a curl request to our Next.js application, so that was on port 3002, and we say we want our request target to be the server that we want access to on that local host URL. If I now hit enter on this, you can see what is returned. It's actually the HTML page for a Python server where it just has that basic directory listing. And if I go back to the Python server itself, you can see that it had an incoming request that actually came from the Next.js application. To better picture what we just did, say in our dotted line here is our deployment of Next.js. So we have our Next.js server, and then also some internal service, whether that's Redis, a database, or any other service. And this one here, you don't want to have access to the public. So no one can send a curl request to this, it will simply fail. It is firewalled and locked off and can only be accessed by the Next.js server. What we've done is we've simply sent a curl request to the Next.js server, and we've said, hey, can you send a request on our behalf to the internal service? And we've got that information back. So we bypassed that firewall by going through Next.js, which does have access to the internal service. The root cause of this one is also pretty simple. Basically, in our curl request, we send an upgrade WebSocket header, and when we send these headers, what happens in Next.js is we get to this piece of code, and this does resolve routes on our URL, but the past URL that we get out here is actually the request target that we send in our curl request. So this is going to be the target that we're trying to reach on that internal server, and not actually the Next.js application. what happens with this parsed URL is it goes through one check down here to say, does the parsed URL have a protocol? But in this case, it's yes, since we're using HTTP, and that is a protocol. So it goes ahead and proxies that request for us. The fix for this simply adds in 2 new guards. On our resolve routes function that we have before, we're now getting a finished boolean as well as a status code. What this resolve routes function actually does is it takes our URL and processes whether it's a legitimate proxy request based on our Next.js rewrites, middleware, and things like that. If it's not, it means finished is going to be set to false. So down here, we have a check. If finished is true, we can move on to the next step. If it's not, it's set to false, so this won't run, which means we won't run our proxy request. And in the case of our curl request that we had previously, that is exactly what's going to happen. Finished will be set to false. Now, if somehow finished was set to true, our next check is the status code. When resolve routes run, we actually get a status code back if the request is a HTTP one. So it's going to be 200, 404, anything like that. So if there is a status code, that means it's not a valid WebSocket proxy request, so it's simply going to ignore this line and not run it. I've really tried to dive deep into these issues in this video, so let me know if you're still watching by commenting something random, I don't know, like Bart or something like that, and also subscribe if you appreciate the content. We've got 2 more categories to get through, but these ones should be a bit quicker, and I'll start out with cache poisoning, where I managed to recreate this moderate issue here, and you can see this one is cache poisoning in React Server component, and it's ranked 5.4 out of 10. To recreate this one, I have a Next.js application, but then I also have a fake CDN to act as if this was in a real deployed environment. This means if I visit my site for the first time on its CDN URL and then click Browse Products and go back and click it again, the first time it should be a cache miss, and then the next time a cache hit. We can see that happen in the logs here. We first had a miss at /products with a query string, and then the next times it was a hit. What I've done next though is I've cleared the cache to simulate maybe the cache expired or something else, and now I can send this curl request. With that, back on my application, if I click Browse Products now, you can see we get a load of gibberish back, so we've successfully done a cache poisoning attack. What I believe is happening here is when we send our curl request with a header of React Server components being 1, this URL is going to return its server component data instead of HTML. Then, when this needs to be cached, Next is going to go through a function which checks if it's server component data or not. If it is server component data, it will store it in the cache as so, and if it's not, it will store it as HTML. This means theoretically, when the user tries to go and get the HTML version of the page, so by just clicking the button, it should never return server component data. The trouble is, in our case, since we had this query string at the end of our server component curl request, it didn't actually meet the requirements for checking whether it's a server component or not, since that simply checks whether it ends in .rsc, but our version ends in the query string. So now it thinks it's HTML, it stores it in the cache as HTML, so the next time a user clicks on the button, they actually got the server component data back because it believed that was HTML. The fix for this one was incredibly simple. When they're doing the check for whether it ends in .rsc, they simply now just ignore the query strings. Moving on now to our final category of CVEs, we have some cross-site scripting ones. This is the one that I managed to get a recreation of. You can see it's a 6.1 out of 10, and it has cross-site scripting in before interactive scripts with untrusted input. Basically all that means is in Next.js, if I have a script tag that has the strategy of before interactive, if I then have another attribute on this that needs some form of untrusted content, for example, this one is coming from the search params, I can do some cross-site scripting. I can do that by making the user click on a link like this, for example, where I've embedded a load of content into that search param. If someone was to click on that link, this is what they would see. So they might think they have to log into the site again. And when they click sign in, you can see here that was an entirely fake login form that was injected via that search param. It essentially allows the attacker to do some JavaScript execution on the victim's machine. So I think a more realistic example would be stealing the session cookies of Chrome to log into everything that you had access to. This one is a pretty simple example of incorrect escaping, and we can see that a bit easier with this more simplified version, but all I'm doing in that search param is I'm first closing a script tag, then opening up a new script tag with whatever I want to run in it. When we hit enter on that, you can see I get that alert that says pwned. As I showed you in my app, the way this one works is we need a Next.js script tag that has a strategy of before interactive, and you also want some attribute on that script tag that takes in its data from some untrusted source. In my case, that is coming from the query parameters. What this does in Next.js is this script tag gets turned into something like this, where we have a dangerously set in a HTML. I mean, it's in the name that it's going to be dangerous. And we also have a JSON.stringify. The important thing to know about JSON.stringify is that it doesn't escape HTML characters like closing brackets. So what's actually happening here is we're taking all of the script tags that we've set up in Next.js, it's looking for the source, which is going to be set here, and then the rest of the props is going to contain data tracking ID, as well as the value that we set in our query parameter, so that gets put into this JSON stringify. what this actually gets rendered as on the page is something like this. So we have our data tracking ID, which was the rest of the props, but then we also have the string which we inserted via the query params. So if we expanded what this actually looks like on the page, it looks something like this. We have our script tag, we have a data tracking ID, but then after this, we actually have a closing script tag. So it ends the script tag that Next.js was trying to do. And after this, we can run whatever script we want on that page. Then we also have this extra bit at the end here, because if we didn't have this, analytics would actually be rendered on the page as text, as the HTML would see this as text. So this essentially just swallows that up, so there's no clear signs that something bad is happening on that page. And there we go, that is 13 CVEs for Next.js and React this week, and how a few of them worked. And honestly, I don't know what to think about this. I hate this, and that's coming from a place where 2 or so years ago, every project I did was in Next.js, and I thought it was the best and the future, but it's just seemed to be hurdle after hurdle, and it feels like they've rushed into a few things and then had to fix them later. Personally now, I am just fully tan stack pilled, and also Astro when I need a content-based site. They just seem much simpler to me, and to be honest, I've also been really liking what Cloudflare's been doing lately, so I've been slowly migrating my projects over there, but I do still have about 20 of them on for sale that I need to go and update. What do you think? Will server components ever be useful, or have we tried them and failed? Let me know in the comments down below. While you're there, subscribe, and as always, see you in the next one.